Everybody in the back, including the people standing there not looking at me right now. Everybody in the back. You are. Everybody in the front. Hello. Wow, this is great. There's a lot of people here today. We're in a fully packed house, so thank you guys all for coming and making the first OSS for AI event in SF a major success. This is really awesome to see so many people here. As people are getting situated and coming in and sitting down, I'm just going to say some things into the mic to take up some time. Okay, who here has seen me before? Raise your hand if you've seen me before. Yes? All right, a few of you. Okay, who here has not seen me before? That's the other half of you. All right, and who's not paying attention? All right, cool. So I think most people are sitting down. I'm gonna basically give a short spiel and then so we are unfortunately missing both of the speakers from Llama Index today. But since this is SF, we do have something for you that's going to be equally as interesting. So I have found two members of the audience who are willing to give a live demo of their product. There's going to be a 5-minute live demo of two products at the beginning. But I would like to know if there is a third member of the audience who is brave enough to come give a live demo. Third member of the audience. Anybody brave enough to come give a live demo? You right there. All right. You will be the third person to come give a live demo. You got to risk it to get the biscuit, guys. All right. So I'm going to pause my loop and I'm going to pause my loop here and I'm going to actually talk about these different things. Let's see. Great, it's on pause. Oh, God. Okay. So my name is Yujin. I built OSS for AI as a way to get all developers the resources they need to understand, use, and contribute to the development and direction of AI. And we do this through online events, in-person events, workshops, all these kinds of different things. And so this first screen I have up here is for that contribute to factor. So if you are a developer and you are looking for a job in open source or AI, feel free to scan this QR code and fill out this form. And then you will be contacted if we find anything that matches what you're doing. So we're building out a, so this will be interesting for you guys. Everybody here is familiar with RAG? RAG, raise your hand if you know RAG, Retrieval Augmented Generation. Most of you guys are familiar with RAG. Okay, so I'm building a RAG app to like match people's like, whatchamacallits, resumes and their job descriptions, that's what. This is for those of you who have not seen me before. I think a large, like 1/3 of you guys were like, yeah, I've seen you before, which is great, which is means like, you know, honestly, I'm based in Seattle. I don't come down to SF that often. So the fact that so many of you have seen me before makes me feel like I'm pretty famous. So that feels pretty good. But this is for those of you who haven't seen me before. I see that there's some phones up, so I'm just gonna keep talking until I don't see any more phones up. Okay, great. Most of you guys can find me on LinkedIn, give me a shout, just like send me a message, be like, hey, we saw this event was awesome. You're awesome, thank you. This is the calendar. So I think most of you guys are probably subscribed to the calendar. I actually have no idea how Luma calendars work. But they have this list of subscribers, and if you subscribe to the calendar, you'll get an invite. You'll get a, not an invite, sorry, an email or an update every time something happens. So I'm doing a lot of weekly events. So this Tuesday, I'm not hosting a tech talk because I'm helping out with Galaxy. So if you're here, Launch Darkly is having their Galaxy conference this week, so I'm helping out with that. So that's why I'm not hosting a tech talk this Tuesday. But next Tuesday, I will be hosting a tech talk, and so you should keep up with that. I think next Tuesday is going to be Lance DB, I think, is coming to talk next Tuesday. So if you guys are familiar with that, come hear Chang talk more. If you're not familiar with that, come learn about what they're building. No more phones up? Okay, cool. And then this is our advertising our next event in SF. So at this point, what I'm going to do is I'm going to take a picture of all of you, and that will be on the next blog slides. Actually, I'm going to take a video. Wait for the camera, guys. Yes. Say hi. Awesome. All right, so our next event is on the 17th. That's the same week as, oh, that's actually CVPR. That's in Seattle. That's not here. And then I will also be speaking at Arise. So if you guys, have you guys heard of Arise? Who's heard of Arise? They're based in SF, right? You guys know these guys? No, really? Wow, okay, cool. So they could definitely use my help then. So I will be speaking at Observe this year, and I've got a promo code. This is a $200 off their standard ticket price. So if you want to scan this QR code, you can use the promo code. It's OSS for AI, which is just the name of the event series, event calendar, company, whatever you want to call it. And this will get you $200 off the tickets to go to Observe. And you can come hear me talk about LLMs and things like that. I think that's enough for me. So let's find the 3 people who are brave enough to give live demos. Please stand up. Gonzalo, where are you? Ayush? Gonzalo, Ayush, and then who's the 3rd person? Okay, cool. So Gonzalo and Ayush, I will let you guys come up here and log into your accounts. Gonzalo, I think you're first. 5 minutes.
Thank you so much. Okay, this will be fun. Totally unprepared. But before jumping into the demo, how many of you can you raise hands if you work in data or AI? Okay, quite a lot of people. How many of you have heard of why data before? Not a lot of people. Okay, then let me ask another question so you can raise your hands. How many of you work in data and AI have problems with data quality? Okay, the same people that raised hand at first. So this will be super useful for you because why data, we work on solving data quality issues for AI. And we do that with automated data quality checks, synthetic data generation to overcome privacy problems, lack of data, imbalanced data sets, missing data, and so on and so forth. So let me start by showing you this cool company called GitHub, where we have a page over there. Yes, I am screen sharing. So we're born out of open source. We became known for our data quality profiling and then later on synthetic data generation. I invite you to give a, well, take a few minutes to explore these packages. They are very useful, can run locally, and you can explore your data set with this. But for today, I promise you, Gian, to do a live product demo. So bear with me that I'll need to log in. This is why I wanted to use your computer before. Everybody can see your nope. Okay, last try, then I'll figure something out. Okay, it worked. So this is Why Data Fabric. It's a data development platform built with the knowledge that we gather from the open source. It is also a free product. If you go to whydata.ai, you can sign up for free and use it for free. And in a nutshell, Why Data Fabric has 4 main models: a data catalog, labs, synthetic data generation, and pipelines. And in here, well, everything starts with the data. We have connectors to pretty much all data sources out there from Snowflake, Databricks, relational databases, uploading files, and so on. As soon as we add a data set to your catalog, we'll automatically profile your data and automatically generate this dashboard with insights on the data, warnings, data quality profiling from a univariate perspective to multivariate, such as interactions, correlations, missingness, presence of outliers, and so on and so forth. Many people come to us because of synthetic data generation. So in order to create a synthetic data set, can be as straightforward as select a data set or a database from your data catalog, confirm all options, all the metadata, combine it with anonymization or combine it with differential privacy, generate a data set by clicking save. And as soon as this generator is trained, you get quality reports and you can generate as much data as you want. Just need to say, I want 10,000 of new records. You can save it as CSV, write it directly to a database, and compare it with the original data. So making sure the distributions are a match, the behavior is kept, and then you can use it either to share with another party, retrain your model, improve your model performance, and so on and so forth. I promise this will be really fast. I'm shut down and we'll be quieting. Thank you so much for watching this. If you want to know more, I'll be seeing you over there and happy to chat about it.
All right, thank you, Gonzalo. I hope you guys enjoyed that. This is very much in the spirit of SF that we're just going to line up some live demos. So next live demo, Ayush, show us Portkey.
Thanks, Eugene. Let me just close this. Okay. Maybe I'll just start with a small context. So before we started building Portkey, I was building peppertype.ai, which is similar to Jasper, Writer, Copy AI, essentially using LLMs to write a lot of marketing content or short format content. And we scaled it up to upwards of 1 million users. And that's when we realized it's extremely easy to do a POC with Gen AI. You connect an API and it feels magical. But actually taking it to production requires a lot more efforts. You need your app to be reliable. You need your app to be accurate. You need your app to be secure. And to do that, you end up building a lot of tooling layers around it, right? And all of that tooling layer, the entire control panel is what Portkey is. We are a developer tool, which enables you or helps your development teams ship their Gen AI apps to production with more confidence. And now I'll show you how we do it. One sec, let me log in. Okay. I think I'm going to open this is incognito itself, I guess. Sorry about that. Jen, you should have given us your laptop a few minutes back. This is SSO. What else do you want, man? You want it secure. Why? Perfect. Okay, so how, there are three main challenges when you are in production. One is it's a sandbox, or sorry, it's a black box. You don't really know what's happening. You want to have full visibility into your application. So once you integrate Portkey, which is literally a 2-line code change, this is your OpenAI SDK. All you're doing is adding, changing the gateway or the base URL to Portkey's gateway URL and passing the API key. Once you've integrated, what's happening is Portkey is that middleware where it's agnostic to the use case you're building, it's agnostic to the models you're building. It just sits in between. And this essentially is an AI gateway, and all your requests are now routed through port key. Now, because everything is routed through port key, you can see exactly your costs, tokens, requests, the full observability. You have like 40 plus metrics to see, what's happening with your application. You can drill down to users, you can drill down to errors. We have a built-in cache. So if the same or similar request comes again, you don't actually have to send it to the LLM. We can return it directly from the gateway. Feedback is essentially the quality metrics. So you could have humans who are evaluating the output, or you could have a bunch of guardrails. You could have runtime guardrails or evaluations that you can all populate that data back to port key. And this is my favorite part. It is essentially the metadata is a lot of your business metrics that you want to attach to each request. Simply key value pairs you can send, and it would show you, what's the total request on. And this list that you're seeing is it's not predefined. It's any key value pairs that you can pass. It's just to give you an idea of what's exactly happening. If you're a multi-tenant system, you want to see how each tenant is performing. You want to see how each prompt is performing, etc. There's a high-level overview. You can come to the logs. You could actually see, go to all the logs, and this is all real time. It's not coming after an hour or something. What was our input? What was the output? You could see the raw JSONs which was sent. And this is the interesting part. So the gateway allows you to implement things like retries. These are smart retries, automatic fallbacks, load balancing. Now imagine you want to implement an A/B test. You were working with model A in production. You find there's a newer model which is cheaper, better, faster. How do you, with confidence, replace it on production? So what you do is you implement a load balance. Say 90% of my calls should go to A, divert 5% of my call to model B, look at the analytics, see how the guardrails are performing based on that switch. It just makes it incredibly easy for you to iterate over things, look at the data, take some action on it, and be on top of what's happening with the application. And the other thing that we do is prompt management. Typically in production environment, you would have prompt engineers who are working independently, and then there is your backend developers who are mostly focusing on other aspects, like how to get the data, how to do the RAG. But whenever there's a change in the prompt, it goes into SDLC and it takes 2 weeks. And it doesn't supposed to be a part of code itself. So this is what we do. So this is your playground, wherein you can write your prompts as templates. These are all handlebar template, Ginger templating, both of them. You can do looping, conditionals, etc. You write your prompt template here. And this is connected to all the 250 plus models. Choose your provider, choose your model, pass in the variable values, and run. You can see everything that happens whenever you update. These are all version. You can go back to previous version, experiment here, try with all the different models providers here. Let's say you want to try Vertex. You can go and check the Vertex APIs. Sorry. Yeah, I want to go to Go here. You would be, I think it's not connected. These accounts are not connected, but essentially you would be able to experiment with all of them. So I have Bedrock connected, so I can see all the Bedrock models and try them here. Once you save this model, what essentially is happening is you're simply getting an API call, which you can give it to your backend team. Now, your backend team only is making a call to this prompt ID, and prompt engineers can keep coming, iterating over here. They can see the performance, how this model is performing, and how this prompt is performing on this model right here. Again, like I said, it has version. You can have a latest, published. You can call by version. It's in that GitHub, version logging, all of that. I think I might not have enough time, but we have virtual keys. This is, now imagine you're in a production environment. You need to give keys to all the developers. Now, it's not safe. You just take the OpenAI key and give it to all your devs. What this virtual key is essentially like a disposable credit card. You bring in a key, define some rate limits to it, define the budgets, and then distribute it maybe per developer, per team, or however. It could also be used to measure how much each team spending on their use cases. So you could just see the costs by, by team. So this is how you can choose any provider, bring in your key, put in the budgets, rate limits, save the key, and just distribute this key instead of the raw keys itself. Config is the core part. This essentially is how you write the rules for the gateway. So I can maybe just show you a very quick example of how do you do a load balance. So here we are doing, hey, I want to do an automatic retry 3 times, which is essentially smart retry. You can pass in the status codes. You can say only retry if it is rate limited, right? So you can say retry only on 4 to 9. You can configure all of these rules. you want a cache, simple cache with this TDL, and you want to use this virtual key. Now, let's say you want to do a load balance. So you would say you could have a strategy, and you have a strategy of, let's say, load balance, right? For this load balance, now we go ahead and define the targets. So we have this target. Target you see is an array. So you could have different load balances, multiple targets within a load balancer. You see, hey, I want to load balance between Anthropic, and I want to have 0.05% traffic going to this. And now I have another target. Sorry. Yeah. And this one is, let's say, any model from perplexity, and you get the point, right? You can define its weight and you can have as many. It can be as complex as possible. Within load balance, each target can have different fallbacks, different caching mechanisms, all of that. And now what you have is a single pane of glass where you can see defined rules for guardrails. I have not shown you guardrails, but you can write your rules for guardrails, probabilistic, runtime, real time, whatever. And now you can see what's happening, both in terms of the LLM performance, cost, how it's performing, etc. You have a single plane to see the request and response. And that's all the data that you need to actually do fine tuning. And that's how powerful it is. What you do is, hey, I want to create a fine tune. Let's just give it some name. You say, I want to create this fine tune on, let's say, llama. So you say, I'm going to do llama. And you have all the data here. You filter this based on the feedback, put in whatever filters you want, and that's it. You say, hey, this is my data for training data. Again, you can upload or filter logs or skip the validation data. We'll tell you how much it's going to cost you, and you can just simply start. I think it's just taking some time to calculate, but yeah, I think this is what the entire port key is. It's a full stack LLM ops. Our gateway is open source. Sorry. Did I spell it wrong? Okay. Yeah. So all of this routing pieces, all of this is open source. Please feel free to give it a try and let us know if you have any feedback. And I think that's about it. I'll be here if you have any questions. Thank you.
All right, who's actually put an LLM into production? Raise your hand. Raise your hand. Have you put an LLM into production? Oh, a few of you guys have. Oh, that's great. Okay. Who's testing their LLMs? Wow, no one's testing LLMs. Oh, one guy. Okay, cool. All right, so we have the time slot for one more person. He's going to be talking about a smart construction chatbot. It's a very unique use case.
Thank you. Hello, everyone. How are everyone doing today? Yes, we need some energy. We always want to have some energy. We always want to play around. And after we're done with work and fun, everything, we go back home, right? And with the pandemic, we are always staying home. So we need to enjoy our home more than ever before. So what if you want to do a small renovation work in your home, right? You want to maybe tear down the wall. You want to add a porch. You want to do something else, right? Anytime you want to do any of those things or build a new home, you have to follow building code. There's different code councils in the world. So just like in computer science world, where there are engineers and designers, in civil engineering world, there are engineers and designers who are building codes. Again, not to be confused with the computer code. Building code basically ensures that a building is safe and sound. It provides the minimum safety requirement for a building to be safe and sound as construction workers are working there or as construction is completed and someone is living there. So the problem here is all those building codes they are very thick book, and it's very hard to go through those books and to figure out to get any answers to the questions you may have. So even as someone who have maybe 5 years, 2 years, 10 years experience in working in construction companies, they may still have a hard time figuring out, going through all the codes. And each, the code are slightly different depending on the state, county, city, and so forth. So the idea here is, why not to make it simple? by enabling the power of AI to solve the answers, get the answers to the questions you may have. So let me log in. So this is basically a homepage. This is a baby step right now where we are. It's nowhere near as complete as the previous two demonstrations were. And it's again on the application side where we're trying to use LLM to get answers to discipline-specific questions. So basically, all the things that comes from the LLM, you can get it here, but only for construction-specific questions. And unlike previous demos where they relied on Google login and they have to use their own login, here's different sign-in. So I'm gonna put a password like an old school way, and then let's see how it performs. Okay, hopefully it'll log in. I just signed up for this new account because I didn't have access to my old account because I didn't have Wi-Fi and a computer. So this is, again, if you're familiar with Microsoft stuff, you're familiar with Contoso. So even the icon and the brand name hasn't been changed yet. So it's very new. So you can ask different questions. And based on the experience, sometimes it gives good answer, right answer. Other times it's just going to say, okay, I have no idea what you're asking about, even though you're asking questions related to building code. So for example, let's say how far 2x4 studs needs to be based on the code. We can ask that. If you're not engineer, if you don't have experience with construction, you may not be familiar with the answer to that question, but let's see what it says. Okay, I asked the question. It takes a while to answer. So now it's looking into the code and saying the maximum distance between the 2x4s, which are the studs, should be 16 inches max, right? So again, those are the type of questions you can ask. The benefit of this LLM is instead of you having to know technical words, for example, the outlets are called receptacles in the building code. If you search for outlets in the building code, hundreds of pages of document, you're not going to find a single instance of that. But because the LLM kind of understands the similarities between outlets and receptacles in technical term, you can ask how far outlets needs to be for a bedroom, let's say. And well, again, sometimes it answers, other times it does not. Anyone have any idea on how far outlets in bedroom needs to be? What's the maximum spacing between outlets where you plug your everything, phones, computers, everything? Very weird question because, again, this is not the crowd who will have those answers, right? It's 6 feet. So if you ever wondered why outlets are not too far or not too close, then the code requires those outlets to be within the 6-foot distance. Now, this is a new code. Maybe in 1950s, that wasn't required. So if you're living in the older houses, maybe the outlets are far. Now, with the newer code, everyone knows it's important to have outlets nearby to avoid fire hazard, because usually the extension cable you add, they are not as strong in terms of its capacity to carry high voltage or high ampere. And that's why they're saying, okay, you need to make sure to have outlets there. Let's ask that question to this. And let's see if it even answers that question. Let's see, it's a hit and miss these days. Whoa, it did give the answer this time. So the demos has been running well. So if anyone's interested in trying this out, feel free. When you go back home, maybe you're thinking about some renovation project, or maybe some of you are pretty young, so maybe your parents are interested in doing some renovation work. Definitely go ahead, log into this sconstruction.app. I'm sorry, sconstructionai.com, or you can put app in the front and it'll directly take you to the sign up / sign in page. So this is the home page. Feel free to check it out. That's all.
Thank you. Cool. So that's it for our live demos, for the on-the-spot demos. I picked these guys to just kind of give a demo on the spot. So, thank you to the brave souls who are willing to do that. A quick question for the audience. How many of you guys would be interested in doing something like this with your own products? Anybody would be interested like this? So we should continue running this. Did you guys enjoy the demos? Should I run this next time? Raise your hand. Who thinks I should run this again next time? Okay, so the majority of you guys find this stuff pretty interesting. Good to know. This is the first event, so we're just keeping a pulse on the audience, right? All right, so our next two talks are our main keynote talks, whatever, the main events that we're coming up. So our first one will be from Alluxio, and I do encourage that you watch all the way to the end and pay very close attention, because there will be a QR code there for you to raffle, for some prizes. So please come up, Lucy and Tariq. There's 3 mics. So I'm gonna take questions. Both the mics up there. Okay. Yeah, I think that should be good.
Hello, nice to meet everyone. The mic works. This is as good as my energy level gets. It stops about right here. But I'd like to introduce Alluxio. My name is Tariq Ben. I'm a solution engineer. Lucy, my brilliant colleague. We're here to talk about data loading for AI and Gen AI. I speak with we both speak with users. She does a lot of the hands-on users. I talk to many of the other users and kind of, some of the people higher up. I'm a solutions engineer. I've been there for more than a year. I think, Lucy, you've been there for probably 2 years or more. Just a little bit of background. Alluxio has a distributed cache and a file system, and it comes into play in a lot of different ways. As we shifted from analytics to AI, we've had a lot of conversations with people trying to optimize their architecture as their workloads and data sizes are growing. And so we get into a lot of those conversations, and I'll talk a little bit about how that plays. Most of you work with platform teams. They have some very common priorities, no matter how big or small they are. Stability, uptime, and a lot of times user complaints, almost always number 3. And Alluxio comes into play very often when it comes to reducing latency with the caching, improving training efficiency, and expanding data access. These are our most common talks with most of the people we talk to right now. And they usually come in with very similar data challenges. Like in a recent conversation, they said, GPU's almost always faster than the storage. And so that's a problem that needs to be fixed. Sometimes they have really huge data volumes that they don't want to move over networks. And so they're trying to increase data locality. So many of them are moving to the cloud or working with multiple clouds. And so they're trying to get data access and make sure that they're efficient as costs go up. And some of them have very long model trainings. And so reliability and availability are incredibly crucial because it's very expensive. And so these are some of the challenges. If you boil that down, a lot of times it comes to throughput requirements, minimizing those cloud costs, and kind of increasing the data locality. I'm going to give kind of a wide overview, and then she's going to go into the the details. And so with Alluxio, a lot of times we'll be serving from cache. You want to do this very often. Faster is better. And then you can also get data from source, but this is very time consuming. And what we found is it's not always really about how much money people are spending. They're not always trying to save money necessarily. A lot of times they're trying to make their architecture as efficient as possible, their training as efficient as possible, because they don't have a lot of GPUs, or they need to get their architecture really efficient so that they can get the data volumes that they anticipate are coming in 3 or 6 months. And so what Alluxio does is it pulls from cache, like everyone knows how cache works, but we do it very granularly. So this could be 1% of your total data as hot data, or 1 to 10%. And so just to talk about the challenges that she'll be walking through, some examples we've had clients or users that have had like 13 hours to load one data set from S3, model trainings that take an entire week or more, or for certain organizations, there may be limitations in certain cloud regions. And so increasing that data locality and reducing that load on the network has been something that really helps them. And so almost all of those issues are solved with data locality. And so I will hand it over to Lucy to kind of talk about the details of how we address those problems.
Hi, hello everyone. I was wondering, just want to extend from the before questions, and how many of you have been using owning your own GPU cluster, or you are experiencing like a GPU on the cloud? Can you raise your hand? Okay, so I'm assuming that most of you are using like a training framework like PyTorch, TensorFlow, or Anyscale Array daily. Can you also raise your hand? Thank you. So basically, what I've been working with is with those data scientists and data platforms to optimize their data last mile challenges. So a lot of time, no matter how much of a design efficient, or like you're trying to do distributed algorithm, and then you're as much as to improve your model's efficiency, training accuracy, you are not going to care about your data, where your data coming from. It's always feeding. For big companies, they have pipelines. They are going to have a data process through pipelines, through other ETL or any other workload, and then feed into the pipeline, and then dump into some shared storage, such as S3 storage, and then share between teams. And each training team, they have their different own algorithm and training frameworks to consume this data set from the upper layer data set, and then to run their own training programs. So what they do care about is their algorithm efficiency. But once in time, like a lot of time, they are sharing their GPU clusters. What they want to do now, everybody's competing with each other, say how many GPUs you own, and then we want to make the best use of our GPU clusters. So that's what we're dealing with, to bring your data closer to your training framework and applications. So to summarize what we have experienced with our data science, they have the last mile challenges, including like data resides in different pipelines. So they have a GCS storage, S3 storage, Azure, everything. They just dump all the big data sets, like hundreds of gigabytes, into one bucket and from a different team. And now they have a multiple training team who wants to consume this, run this data set, and then into their feeding into their PyTorch, Anyscale Array, and then TensorFlow to train this particular data set. So, and the data is having different modalities. Sometimes it's unstructured. They may have images, videos, audios, and sometimes they're structured. Some people find this big data kind of too much, too many, 2 billions of hundreds of billions of small files. And so they do certain like decoded image array into a big data format, such as Parquet, and also Mosaic provided by Databricks format. So to combine these small files into a big data platform, big data format for these training framework to consume. So once in the infra team specifically, what they are going to see is the multiple buckets in different area, different clouds, and the data set is going to be different, the format. And the third is that the different data loading and then pre-processing. Sometimes for images you want to transpose, and then sometimes you want to shrink the size of it for your training framework. So there's multiple different traffic patterns. You want to read the data for once and then just start training them. Or if it's a distributed, then each of the node is gonna read the data multiple times for each epoch, for example, right? So these are some data bottlenecks or problems that a training team won't think of. They always dump the problem to the infra team to resolve. So just to give you a top-down, like a layered structure of how this infrastructure is going to look like from the big picture. So training team own use a framework such as Array, Anyscale Array, and also PyTorch, TensorFlow, sometimes Ray plus PyTorch, TensorFlow, XGBoost together to run their model training and inferencing. And in the storage end, so these are all compute layers. For storage layers, you have Azure, Amazon S3. Also some on-prem, you will employ some all-flash kind of SDS solutions. But in between, there's always a lack of kind of a data access layer for you to access your data, bring your data more closer to a computing algorithm. So that's where Alluxio comes in. Okay, it's served as a high-performance data access layer for your compute engines. So for Alluxio, Alluxio is designed to serve in this scenario, serve as a kind of a distributed cache, and so it's designed to. First of all, it can scale horizontally with the linear scalability that you can spin up one node for a tryout POC use cases. And then when your teams are growing, like multiple teams is running, is going to have hundreds or terabytes of data set, you linearly scale out horizontally by adding more pod or machines to your Alluxio cluster. Okay, and it's been tested to be able to cache 10 billion plus objects without single node failure. And for one single node, it can also design to cache like 15 million objects. So performance-wise, this is particular really important for these data platforms. So we design in a sense to serve those workload-specific optimization for ML training and model deployment. So oftentimes, like for storage, they have they put a lot of focus on writing and then like make sure the data have a resiliency and the data is correctness, integrity, and all that. But Alluxio, on top of that, Alluxio will be putting more focus for the specific training workload for ML training. A lot of the time, these are data sets keep loading, keep reading with a very small amount of modification to the data set, right? And they keep reading the whole data set, listing all of them, and then getting all the files, and then ingest into their training framework. So we design to serve that particular traffic pattern in order to offer low latency of reading and also high throughput. So with the linear scalability design, we could achieve hundreds of gigabytes aggregatively from one single Alluxio cluster, okay? And then for reliability, so Alluxio serve as a layer in between compute and storage. So even if Alluxio is not able to cache your data completely, you can always fall back to the data lake storage where you have reliable storage sit at backend. So this is the Alluxio design goes. And so how do you access Alluxio from ML framework? So we offer two solutions right now. First off is using Fuse, which is access Alluxio as a local file system. So oftentimes if you want to say a torch, our torch have a PyTorch data loader from a local disk, right? You just given the OS path, and then once you want to do checkpointing, you save back to the same local disk. So and then similarly, you do not need to change one line of your code. You just have a mount point to your training pod or training machines and expose Alluxio as a local file system, and you can just read the data set. You can only expose one particular data set for your team to read it from, and after that, you can just deregister this particular mount point, right? So this is the first solution, and second is called FSPAC. It is a kind of Python world file system interface to kind of serve as Alluxio Python client to access Alluxio. I will dive into deep on this. So first, look at the first solutions for POSIX API, which is Fuse with the Alluxio cache cluster. So now you have a training node over here running PyTorch programs, and you will spin up your Fuse pod. A lot of customers want their they are using Kubernetes environment, so they want to separate their training node from the storage node. So, but for Fuse, you have to spin up in their training node for PyTorch to talk to that particular mount point. So the workflow is going to look like this. For data scientists, you only look at this blog over here. This is PyTorch. You're going to talk with the Alluxio Fuse mount point using POSIX file system API, ls, cat, whatever, stat to read of your files, and then PyTorch will get the result from it. But internally, what Fuse pod does is these are the actual cache cluster component. We have service registry and the cache worker where the data actually resides. It will utilize the local NVMe disk to cache the data. And you will also, so this is very kind of a simple layout. For the Fuse pod, it will just trying to get the cluster info of all these data worker node. And we actually partition or distributed our data for these cache workers to form a consistent hash string, so they know where to go, where to find this data. You just pull it from S3 storage, right? And then after get the cluster info, you will find the particular worker. And if you find the data over there, then that's great. It's a cache hit. So it's going to return this hot data to you through Fuse to your PyTorch. And if it's a cache miss, we'll always have a way to fall back and read from the under storage. And then depends on your needs, you can read from there and cache in Alluxio again and return. Okay, so next time you trying to reach the data, it's already in Alluxio. So similar here, Fuse also have the capability. Say for any reason, the storage nodes, storage pods, all nodes, say like 10 nodes, they're all done from the AWS region. And then the Fuse pod has the capability to fall back to the under storage. Okay, so it's a multi-layer kind of cache. So for a lot of customers are using Kubernetes. So as I explained before, Fuse container will be configured to run on the training node, and then we have our own Kubernetes operator to help you with a one-click kind of install Alluxio either to your A100 like GPU card clusters, and then a lot of time these GPU nodes are equipped with a 1 or 2 NVMe, and you can utilize that particular resources. So so for Fuse, you can either run as a daemon set. It's a spin up as an application pod. It's long running. It's spawned at time of deployment. It's less of debugging headache, but it's also resource consuming. And you can also use a CSI to manage your storage resources, and it will launch the Fuse pod when needed. Okay. So here's is a demo example. So we tried ourselves using a GPU with just run a very simple ResNet 50 with 3 epochs, and we're trying to see how much the data IO bottleneck shows up in here. Okay, so with this simple training program, and we're having this public data set, which is having 1,000 classes and then 35K such images, and we train them for 3 epochs. We can see that the GPU utilization is very low. It's only 17%, and a lot of time are spending on the data loading part. So after employing Alluxio, so you are still accessing as if you are accessing S3 through the local file system. So run the same program again. So now you can see the GPU utilization has jumped up to 93%, and it only spend 1% of time in data loading. Okay. So with Fuse, to summarize, it's a good part, it's advantages, it's directly out of box. So it's a one click of a Kubernetes like an operator to deploy on your cluster, and it's a kind of a one click kind of thing. And sorry. So it's a zero code change. Whatever you're using your program for single node, like using the local disk for your PyTorch script, you can just use as is. And zero code change, zero migration cost. You can access your backend storage as if it's a local file system, right? But the cost, there's also a little bit of a cost as Fuse introduce additional pod, right? It consumes additional resources and to serve as a middleman to proxy the conversation between you and the Alluxio cluster. So there's certain some overhead in ops, and there's also maintenance headache. If you want to look a pod is down and you need to bring it back up for it to consume again, certain kind of maintenance cost over here. So the second way, so there that brings them to my second solutions. So it's accessing Alluxio with FSpec API. I'm not sure how many of you have heard of the interface FSpec. Can you raise your hand? Oh, okay, cool. So FSpec, to introduce FSpec a little bit, FSpec is kind of Python file system interface where it lists a lot of APIs such as ls, cat, info, stat to simulate the POSIX file system API. So whoever wants to implement their own file system can use this, can implement the FSpec APIs to bring up your own file system. So that's what FSpec is, a Python world file system interface. Okay, so similar here. Instead of having two separate PyTorch pod and Fuse pod, this will be closely integrated into your PyTorch script. So internally, using the OS path as a way to access data, you will import the Alluxio FS library, Python library, and then for you to iterate batches of images per K, and then we will return the send result data to you. Currently, the way of usage over here with our customer is that they will always doing preload to load your entire data set, hundreds of gigabytes, to Alluxio first, and then you started to make that data hot, and then you use this Alluxio FS to do the same workflow, get the cluster info, trying to get the worker, and then if it's cache hit, and it will return the hot data to you, and if it's a cache miss, the Alluxio FS will directly fall back to the S3. So it's a little bit nuances over there, but still the ideas is the same. Okay. So, so this is some like a code example. If you're using AnyScale array, and so Ray have their own module called Ray Data that is specifically trying to solve the data problems within the AnyScale array training framework. So similarly, so how to use that? They will have multiple different APIs to read images, read Parquet from different cloud storage and from database, and you just need to add one additional parameter called file system equals to Alluxio, and import the relevant Python library, and you can directly using Alluxio as if same as a Fuse does. Okay. And so yeah, so this is an example using Ray data to access Alluxio. So a lot of things are Ray. The people using Ray differently for XGBoost, you might just load the data once, and for PyTorch, it's going to load multiple times for each epoch, right? So with the Alluxio FS Python library, you won't be suffering from the cold start every time. So this is a kind of a experiment we run in-house to show when reading a large Parquet files, how much of a difference, how much of a difference in processing the images per second is going to look like. It's now even better, but it will introduce like a 2x or 3x kind of speed improve while you're doing your data access. So to summarize, with the FSpec solution, it's a direct access Alluxio. Before with Fuse, you're going to go through Fuse process and then go to Alluxio clusters, and you need to deploy your Fuse pod. But with FSpec, you can directly access Alluxio within your Python world, directly talking to Alluxio data nodes. No extra container, no extra resource consumption, and no more system admin permissions. And it abstract away low-level file system details that you do not need to care about what kind of a POSIX API are happening when you're trying to do read file. So, and with Python world, a lot of people are doing native capabilities to employ CPython or Rust to provide more to bypassing certain Python GUI kind of drawbacks. And this is also a way for Alluxio. You can also using Alluxio for that particular capability depends on your workloads. It's very highly customizable. So, and the cons is that there will be certain code changes to import the Python library externally. You need to install that for your training code. So to summarize, so Alluxio is a distributed cache, and it provides data access from the cache cluster to improve your local GPU or on cloud GPU usage. And you can access Alluxio with two ways. One is a libviews, and the second one is fsback, the Python library. And the fourth, we reduced the data loading time and the code. We trying to resolve the cold start problem in distributed trainings. You want to show?
We're not going to show this video. We'll follow up and you can see this video is very short. Nope. How do I get past this video? All right. Thank you very much. And if you have any questions, we appreciate it.
And we will encourage people to scan this QR code right now and then to get more information. Thank you.
All right. Are there any questions from the audience? Well, I guess everybody's scanning QR codes. Your screen is no longer up.
I suspect those are once your cache is kind of filled up with the data. So like if I were to go and like fetch some information, initially that's a cache miss. There will be no performance improvement, right?
Yeah. In that sense, like we all often because before training, you always know how much of a data set how large of data set you're going to cache, and then you always preload those data from the under storage to the cache. If it's you cache 90% of the time, you get 90% of improvement. 10% you will just fall back to under storage. Yeah.
Have you compared performance when it comes to like directly accessing S3 versus accessing S3 through something like CloudFront? You're asking about this experiment results, or
Yeah.
Have you compared that? Like if I put CloudFront in front of my access to S3, would that improve the speed?
We actually haven't done that experiment before, but the concept of Alluxio is that not just for S3, right? It's for multi-cloud and then for different Azure, GCS, some in Asia, there's Alibaba Cloud. And then we can always serve as one piece of data access layer for all the clouds.
Thanks. And just last question, what's your business model? How do you make money? What's your business model?
We actually,
yeah, that's not her second. So we have there's enterprise. And so there are security features and other things like that you can do, not just the open source. And so it's basically, we deal with like a lot of either very small people doing trainings in all three different clouds or very large companies trying to do multi-cloud for strategic reasons. And usually that's enterprise.
Cool. We have time for 2 more questions, I think. Any other questions? Oh, Frank. That's right. I remember your name. So if you tell me your name.
So does Alluxio support any prefetching? So if I'm doing training in the middle, I want to do, let's say, I'm doing some gradient updates, or if I want to, test the performance of the model in the middle, does it support prefetching? And if so, how does it do it intelligently?
Yeah, so we support by a command called distributed loading, basically just a pull for all these data nodes to pull aggregately for all the data set from one location, one URL. And after it's done, and you can start accessing, and it's if all the data set fits in your Alluxio cluster, then it's always going to be cache hit, and it's always hot data. Yeah.
Okay, and I have one other question, which I might have missed it in the slides, which I apologize if I did. It seems like you support, there's Alluxio FS for Ray data specifically. Do you support something similar for pure Torch, pure PyTorch, or pure TensorFlow?
Yeah, so the thing with the Ray data is they directly support the FS spec out of the box. So it's very easy integration. And then for different other frameworks, such as TensorFlow and PyTorch, some of our data science, they will have their own implemented data loader. So we will have, with our Python client, it's pretty much you can write your data loader at any time. But oftentimes the people write their own data loader using their own script or anything, which doesn't employ FSPAC. If you employ FSPAC, it's an easy integration. You just register Alluxio as a file system. If it's not, we'll think of something else and then import this Alluxio library and then take a look at the API inside, provide it, and then do the integration. Yeah.
Okay, thanks.
Cool.
Nice. Anyone else? One more question. Okay.
So in the case when something is not in the cache, how much latency would Alluxio add when it does not find something?
It doesn't quite add much of latency. It just bypass everything to the cloud. So yeah, it serves in that particular case, it will just serve as a proxy to transfer everything back to the under storage. Yeah.
Cool. Thank you guys. If you guys have more questions or you're too afraid to ask questions on the mic, please feel free to find these guys later. I think, yeah. Has anybody not scanned the QR code to join the raffle? I think we should leave this up as long as I see any phones, and then we'll bring up our last speaker of the night. All right. Good.
Thank you very much.
Thank you.
Dimitri.
Almost. Hello, everyone. Happy to be here in GitHub space. So I'm using GitHub like every day. My name is Dmitry. I will be talking about data versioning in generative AI and about cost efficiency. So super vague subject. But more specifically, we'll be talking about evaluation of LLMs and efficiency. A little bit about myself. So first of all, I created open source tool DVC, data version control. It's a tool to manage unstructured data. Some people might be familiar with this. And I'm working on this tool set for like about 5 years. And today we'll be talking about some like next steps, what we are doing on DVC, what will be like released later on DVC. But before I was data scientist at Microsoft Bing for numbers of years. It's a search engine, right? And surprisingly, today with LLMs, a lot of practices, ideas from search engine actually are using in the modern LLMs. Like RAG is basically like an index, right? Uses an idea of index. Evaluation and choosing like a right answer is basically idea of ranking, right? And today I will show you like some analogy with search engine and how it can be applied, at least on an idea level with LLMs. So if you're working actively with LLMs, and at least like if you observe like how LLMs are developed today, you see like they are not ready to be like used in production. There are a lot of challenges. So no deterministic result, right? You query like numbers of queries, and query like sometimes getting you like a not a stable result, right? You change your prompt a little bit, result change like to opposite, right? And then cost. Models are changing. You start with some smart GPT-4o model, then you go to Turbo, then you go to Anthropic, then you go to Llama, and so far and so on, right? Like you are jumping back and forth, and of course, result is absolutely not stable. How to deal with this? The good news is, like we have been there before, right? When you work, if you had experience of working with in a complicated, complex machine learning systems, right? And search engine is like probably like one extreme in this sense, right? You very likely familiar with this set of problems when dozens of models are involved in to answer like one single user query, right? Sometimes, I mean, 20 models, sometimes like 2 models, sometimes 1 model, but there's like a whole cascade of these models. None of those produce like a very accurate result, right? But at the same time, the system gives you like really good overall performance and quality. How people achieve this? And the short answer to this is evaluation. Evaluation is happening on search engine like everywhere. From the evaluation of the final result in production, if you build some model, it will be like evaluated first, proven first, and then it will be like put like 5% of traffic on it before, right? It goes to production, and only after this, it will be like fully deployed. And what I see is something similar is happening in LLMs today. And today we'll be talking about like some simple evaluation ideas and techniques. Example would be like a chatbot. And we are not building this chatbot, we are evaluating this chatbot using LLMs. The questions are how to quantify result of your chatbot. That's the first question. Like if you want to evaluate something, if you want to measure and manage something, that's the first question, like how to get the numbers out of it. How to evaluate your models, prompts, and how to manage the life cycle of this process, right? And the first part of the talk will be like kind of in general. We'll be using that simple evaluation examples. And the second part, I will show you like how it works with the tools that we are building. It will be like a real kind of demo with Jupyter notebooks and all the stuff you like. All right. The data set we are dealing with is openly available chat, some logs, some companies with research institution provided this like a few years ago. There is 79 dialogues with users and a bot when bot suggests some mobile plans for the users. So that's a real people, and there is some bot. It's not a RAG application, it was like years ago. But the same ideas can be applied for RAG application or anything you use. So 79 dialogues. This is how it looks like. So bot like cheers the user. User asks like what they need, right? And then bot suggests like a plan. And we need to evaluate. First of all, we need to kind of quantify how to understand if the bot is doing a good job or not. And we can ask LLMs. You can formulate like a naive question like, hey, LLM, like there is a user asking like for a mobile plan, is it like a good dialogue, productive dialogue or not? If you put like naive question, right, it will be, you'll get like a naive answer. In a more kind of realistic prompt will look like this, right? It will be like a bit more complicated. It will specify the roles, what they're looking for, what the input format, output format should be, right? In this case, we are saying, give me like output in success failure format. I need basically like one binary answer to this plus explanation why, right? And result should be like a JSON. This is like what this prompt says. And then we need to run this prompt on top of our like corpus of the of the dialogues. In this case, the example is like simple, right? Like 79 dialogues only. In reality, you'll be dealing like with hundreds, maybe thousands of samples, and sometimes with, in some extreme cases, like with millions and hundreds of millions, right? But let's focus on this use case. That's simple, 79 dialogues only. What we need kind of like a table, right? Success, failure, and the reason, right? That's the table we need to build. And it gives you like it gives us a good foundation for the evaluation, for the next steps of evaluation. And the first metrics we can compute, right? It's like that simple, just success rate, right? What is success rate for our chatbot, right? And in this case, we got like 73%. Is it good? Is it bad? I don't know. Actually, it's really hard to say until you have like a ground truth, right? Without ground truth, I don't know. Let's assume that's like a good result that we can trust. And in this case, we are using Cloudy model, the most powerful one. So probably it is smart enough. The next question is, okay, we need to play with prompts, of course, right? Because the prompt can improve the quality of this result. And also we need to play with different types of models. So from the powerful model from Opus, right, which is the most expensive one, most powerful one from Anthropic stack, we can try like a cheaper model like Haiku. We can do like some on-prem model. There is a bunch of open source models today. So that's like pretty much every team are doing today, right? You start with the most expensive, most smart model, and like next week, you're already running like open source model and getting pretty much the same quality for a small fraction of the price. So that's what we will be analyzing today. And so that's example like how you can quantify result, how you can quantify the spending. And when you do the evaluation, by evaluation, you usually need not only the quality of the response, but also the price, like how much we are paying for that, right? And for Anthropic, the powerful model, the price is $15 per millions of input tokens, right? 75 for output tokens, right? You can multiply everything and got the price. So in this case, again, it's like a little bit toy example, right? 79 dialogues only, and we already paid like $1.40, right? In reality, you are dealing with thousands, millions, so this price would be like a very different, like substantial. So what next? That's a simple rate, but probably like when you do the analytics, you need to go deeper. When model makes mistake, how to check this model with another model, for example, with the Haiku, with the fast one. And that's the result you can come up with. There is a confusion matrix, which shows you like result with Opus versus Haiku. Two different model, price is different in an order of magnitude. And the result is, might look very acceptable for your application, right? If you look at the success, failure rate, right? Like when the two models agree, you see that majority of the question follows to this bucket, right? 43 plus 16, and only 20 disagreement between the models. That can give you like some ideas like what model to choose. The same way you can analyze different types of prompts, right? With the statistics, you can go like a deeper and deeper. But that's can show you like some action points, what to do with the model, what to do with the prompts. So you can decide if this range of metrics is acceptable for you, right? So, okay, we got like a 20 mistakes out of almost 80. If this difference is acceptable for you to kind of try this another model, or maybe you can consider that this rate is not acceptable for the bot overall, right? No matter like the powerful one and a cheap one, we should probably do a better job of getting better result. In machine learning, you should not expect like 100% results, right? That would be like a little bit naive. But you can say, you know what, we are getting only like 80, like something percent, like 60, it's 60 or 79, right? Only this result, probably we need to like go like above like 90%. And maybe you need to add more agents or expert to the system, or maybe you can include like a human to the loop. So that's very simple analytical question can spotlight first of all the problems, and second the kind of like size of this opportunity. If you include the person to the loop, right? How much you can improve this result. And of course, cost, right? We already discussed like a expensive model versus like a fast model, right? And then you can think more about like how to run some open source, how to modify the prompt that you will be spending less output tokens, for example. So a lot of different ideas you can come up with if you have this like overall picture. And the big part of this evaluation is like how you collaborate within the team and how efficient you are in this like management of your artifacts. Because if you work on this application, like in just a couple of weeks, you will end up with hundreds of those artifacts. And each of your team members will get like quite a few, and you need to deal with this somehow. And some research show that the price that teams spending on the collaboration and management and versioning, it's a 3 times more three times bigger than the overall price of the development of the LLMs, right? That's not a surprise because we don't have like a standards, right? We don't have like a GitHub, like what developers use, right? We kind of like inventing these tools and of course spending times to collaborate on this. And so like when you work with these tools, of course, it's crucial to have this, at least a simple way to save your result and share with the teams, right? And with all the like versioning included. So we'll show you later. All right. That's the theoretical part. Now we will go to the demo. I will show you like how it can work in a practice using our tools. Yeah, but some ideas behind the tooling. So what problem you need to solve to make this analytics efficient? First of all, you need some like a good framework to capture this like data together and derive the metrics. And at first glance, you know, like there is a long chain and a lot of tools around this, right? And it seems like the best tool in the market for doing this. But in fact, majority of those tools are optimized for online application. They're great when you build application. But when you want to analyze, it's kind of like not their use case. They are like an ability to like capture this meta information. And for analytics, this is like when you get all the insights. You need all possible data. What prompt you sent, what result you got, what response status you got, how many tokens you spent, and so far and so on. And you want to version like everything single request to get the whole picture, right? So data frame like pandas and such, that was built for analytics. You have like beautiful tables, you can calculate these basic statistics, all good. The problem is they are not kind of connected to the LLMs. You need to build some connection. Second, you want to run this in a parallel way, right? Because you don't want to wait for the like small, like long responses for LLMs, especially in distributed compute when you run like your model in a multiple machine. That's super painful. And good versioning is not supported in this kind of frameworks. And databases, and especially data warehouses, the best for the scale. Because in majority of the cases, like at least on the enterprise cases, you want to do these analytics, you want to do this evaluation on top of the millions, sometimes like hundreds of millions of objects like one PDF file can generate like several thousands of documents, right? Or if people do like computer vision, there is usually like a usual scale is like a millions of images, right? Databases, great on the scale, but not good on the other different aspects, right? So you still wanna write code because like whole the framework is like a Pythonic, right? You need to kind of connect this. There's no connection between the data in the data warehouse and your Python code. Hard to connect to LLMs, pretty much the same problem as data frames. And so that's basically the world we are living in today, right? So a lot of tools, each specific tool like good for their own purpose, but at the same time, like what we can use for LLM, that's big questions. So that's what we are trying to do with like DVC, next step of the DVC. We want to introduce these capabilities to the framework so people can work and evaluate their LLMs, their computer vision application in a big scale using like modern framework. So let me show you how it looks like. One sec. All right, I'm not good at coding by one hand. All right, so we will be running this like Jupyter notebook. First, let's start from scratch just to make sure. Okay. We are including library. That's the prompt I showed you in the beginning. We import Anthropic, and there are two models, right? So there are two constants. One is the powerful one and the fast one. We get data from the storage. So in the storage, there is a dialogues as a file, right? We like take every single file. So you can look at the files. And now we need to run the Opus model. The Opus model with the prompt and the file. So basically it takes data from the storage, right? Applies the prompt and kind of send the request to the Anthropic. So 79 files only, not a big files, like kilobytes. We're talking about kilobytes. A couple kilobytes here, 10 kilobytes there. So nothing special, but it still takes a lot of time. And you can see that to the speed, right? It's like a 1 row per second, right? And this is possible only because of parallelization equals to 4, right? If you run like one by one, it will take like about like 3-4 seconds for each response, right? That's kind of like how this heavy, powerful LLM works, right? With my account, I can use like 4 requests at the same time, right? With a bigger account, you can use like more. But the point is like it's really crucial to do this parallelization. And it's especially important when you do like when you run your on-prem models, right? And it's not even parallelization; you need to like do the distributed compute. Anyway, so we about yeah, it will take maybe 10 more minutes. Sorry, a second. Here we go. So 79 rows, right? It's all done. You see the records of the files, and that's the result. So success rate, success, failure, and here is the reason. And next to it, we to the reason we see all the input token, output tokens. So like all the information we need for analytics, it's here, right? And now we can calculate like all the stuff that I've seen before. So the rate, once we get this kind of like a data frame, let's call it this way, you can easily like get this success rate, right? Just divide the number of successes by number of all the items, right? You can take a closer look like how it looks like, or maybe even like do the list, right? So that's with a more detailed information about like why it was. So the first was successful, why it was successful, or why it was failure, right? Those two like failures. So you can deeply analyze and modify your prompt, for example. And now let's do the price. So this information contains all the result of the response, right? And we can like summarize the input token, output token, multiply by price, and see how much we spent for this. So, well, yeah, here we go. That's the price, right? That's the powerful model. 15 per million requests for inputs and 75 for outputs. So we put the numbers here and run this stuff. So yeah, pretty much the same number we got before, right? $1.40 to run 79 dialogues only. Okay. So, and why don't we try the same thing, but for the Haiku model, right? So we store this result in some variable. It will be like our opus. And now we do the same thing. So the data start here, the same files, right? No reason to read the files again. But models is going to be a bit different. Haiku. Okay. Let's look at this one. It should be faster because this model is better. It should be faster. It should be smaller. 4 rows per second. It was about 1 row per second today. And you see, it's almost done. Last time it takes more than a minute, like a minute and a half, about this range. Now we got result in 24 seconds, much faster. The same, absolutely the same schema, right? So success, failure, reasons. We can look at the, success rate, right? So it was 62 with the powerful model. With the fast one, the response is 74%, 75 almost. So the fast model a little bit more optimistic. And again, is it good or not? It's really hard to say without a ground truth, but that's you can evaluate if you have like an actual label to this. Okay, the same here. There is a reasons and the price. Let's take a look at the price. So Haiku 25 cents and $1.25. So 25, no 25, 125. Here you go, 2 cents, 2 cents. Yeah, seems more affordable. And if you got, so we store this result to Haiku. And now we got kind of like a two different table, if you wish. And then you can analyze those two together, right? If you join them, like how to get the confusion matrix we got before, right? For each file, you need to get like result from the one model and result from the other model. So you need to kind of join those two. And let's do this. So you can just simply like naively join and see. But maybe that's not what we need. We do need something like better. We are joining only the columns signal that we need. And on the next line, we compute the confusion matrix. So, and here we go. That's about the numbers we've seen in the presentation, right? So it's changed a little bit, again, because it's not determinism. 16, 45, and there is 18 mismatches. Last time it was 20. But this gives you like some ideas like what to do with this. Is it realistic to switch from the powerful model to the fast one? Maybe you can analyze prompt, tweak prompt, and work with this. And then you can just save the result. And next time, I know, tomorrow, the result can be obtained with the maybe version specified or maybe the last one. And then you can get, you can continue your like analytical evaluation work tomorrow, right? And the beauty of this approach is like we want to utilize all the powers of the data warehouses, databases, right? Because sometimes you need to do this on not on 79 dialogues, but in thousands and millions and maybe hundreds of millions, right? So under the hood, we want to utilize database. So in this case, we just put like a SQLite. So that's probably not the most powerful database, but it gives you like, let me show you how it looks. Tables, right? So we save the data set as a rating corpus and rating haiku. So you can find corresponding tables. So opus, rating opus, right? This is version number 3 at the end, right? You can look at the table. Oh, let's do some, I should have something. Yeah, here we go. So the file, the rate, the tokens, if you want a reason, you can include the reason signal, but you got the idea, right? It not only helps you to like analyze this, but it helps you to analyze this in a bigger scale, in the scale that you need, your company, your team needs. All right. So yeah, today LLM become like a part of our life. People really want them to be stable. And stable means not necessarily give you like 100% correct result, but they need to be like statistically stable, if you wish. And the team just need to decide like, what does it mean? What is the range of this stability, which is acceptable for the business, which is acceptable for your application? And this like evaluation frameworks, evaluation approaches, that's what helps you to achieve this. And that's how we can build robust, good, powerful LLM application. But you need a good tool set for this, to get statistics, to get connector to LLMs, with a parallel execution, with efficient execution. So that's what helps you to build your application to the production faster. All right, thank you. That's what I got today. Very open to your questions.
All right, who's got questions? I've got the mic.
Yeah.
All right, guy in the Puma t-shirt. You've got a lot of questions. I love it.
Just a quick one. How do you guarantee that like the prompt that you're writing to the LLM is correct? Like what's gonna happen if I write a prompt which says, whatever data you input in me, always answer success?
I mean, we don't do this, right? We build tools that helps you to run this like in a scale. So, and of course, you can put like any stuff, right, and get like some, I don't know, not expected result, right? Our job is to run it on a scale. If something happens, like some error happens, to identify these errors, right? I haven't shown this use cases, but that's like a good portion of this analytical work. Yeah, so that's basically not our job, right? To write prompts. Our job is to help you to run this on a scale.
Maybe I didn't get it, but what is your business model and who is your customer?
So we have open source, right? The stuff I showed you, it's not open source yet. But our DVC product, the original product, is open source for like 5 years. We have a lot of customers, and some enterprises are paying us for the SaaS because we have like additional feature on the SaaS, which is like not part of the open source. That's how business model works. Interesting part about the new product. The previous one we started with open source and then built SaaS. The new product we do like opposite. We already have customers, paid customers. At the same time, the open source will be released later. So we kind of like switch this dynamic a little bit this time.
So the tool provides a reasoning for why it gave a specific run a success or failure, right?
We kind of like, that's not part of our tool. That's like what customers kind of wanna usually answer. Our job is to kind of like capture the result, right? So you're asking like some question to your, I don't know, images, for example, right? Yeah. I don't know, like how many people in this image? And there is a corpus of, let's say, like 100 millions of images. And then you run this on a scale, right? That's our job, to run it on a scale and get like a one single number for each image and store it correctly, right? The same with the LLMs. You provide the prompt, you provide the files, or maybe just records, right? How to run it. And we do this.
Yeah. I guess, how can we, the user, have confidence that it's grading it correctly?
Pardon?
How can we make sure that when it's saying this is a success or this is a failure, that that's actually correct?
Oh, that's a good one. So in general, only ground truth can answer this question, right? For example, like these dialogues, right? Is it a good dialogue or not? For example, like bot suggested some plan and users say like, thank you, right? Is it a good dialogue? Maybe it is, but maybe this plan doesn't exist, right? How do you know? You need a ground truth to answer this question. That's one way. And another approach, it's very different. And I believe like we should use this approach more. It's kind of statistical approach. When you say like, okay, there is millions of dialogues, right? And I run something on a scale and kind of I simulate this result and I see how its result is changing with some small modification of my prompt or something, right? So you see like how stable your prompt is, right? So that's kind of like a two fundamentally different ways of estimating this.
Okay, awesome, thank you.
I might have missed this, but can you explain a bit more about the interaction with a storage layer? So are you guys like a layer between the storage of choice, or how do you interact with the customer's storage layer?
Yeah. So storage for us, it's a big part of the story because DVC originally started as a data version control tool, right? It connects your unstructured data from S3, from NFS Drive, Azure, etc., right? To the training cycle, right? So, and we have like a whole like bunch of tool set to do this connection. So in this use case, example was very simple. Okay, there is a directory on Google Drive. Give me all the files, and for each files, I want to apply some prompt and give me results, right? But it might be like way more complicated, like millions of files. Apply this model to identify when it's like, I don't know, this particular subject is discussed, right? And et cetera, et cetera. It might become very, very complicated.
Thank you.
Earlier, you said that you had reversed your business model from your first product to your next, and for the one that you're working on right now, it started with enterprise, and you're going to later release it to open source. Why did you reverse it?
Why did you reverse this time?
Yes.
Well, for numbers of reasons. First reason. It's a little bit easier to build with the customers, with the paid customers, because you can get like a better feedback, right? And when you do like open source, it's a little bit like a kind of like a high scale game, right? And from this like high scale, it's really hard to get like patterns of the signals, right? So that's like one of the reasons, like why don't we do like this way when we can directly interact with the customers, right? Second reason, to be honest, when we start this project, we were not sure what exactly we are building because it's space AI changing so rapidly, like every 6 months, something changing, right? And now what I see, it's a little bit stabilizing, right? I mean, I'm talking about like past couple of years, right? In a little bit stabilizing, if I start this project today, maybe I would go like open source first. But it was definitely like one of the reasons. And the third reason, of course, it's about like money, revenue, and such, right? So it's usually like it seems like a clear pathway. Okay, let's go customers and focus on revenue instead. But it's a question mark because sometimes like a good open source traction establish like a stronger foundation in the market.
Wait, can I clarify the second reason? How does the stability or the rate of progress affect whether to build open source or not? For your second reason.
You mean how the changing landscape?
Yeah, the
affected
fact
the
that it
decision?
changes less now, why does that make you say that you would be more likely to build open source?
So we started this project like almost 2 years ago. And back then, it was clear that Gen AI is going to be huge, right? Because stability, as far as I remember, was not released yet, but it was released like a couple months after this, right? LLM was not there yet, but everyone expected, oh, something has happened with LLM, right? And then here you go. And when LLM first released, it was not clear how people will be using this, right? Even today, like you read these papers, like, you know, like 5 months old, and you're like, oh my God, that's old one. I'm not reading this, right? So it's changing too fast. So that's like one of the reasons.
Thanks. Cool. I think we can have one more question. If there's any more questions from the crowd. Chat? Oh, okay.
It might be a weird question, but in the beginning you say we can refer to the search engine in terms of this versioning things, but I didn't hear like why this versioning on LLM is similar to search engine. Can you elaborate that a little bit more?
Yeah, so the reference to the search engine was about evaluation, because search engine, it's all kind of like a quantitative machine, right? It's all about the numbers. For example, I built a model, right? And first question is like, okay, how good this model is? Show me the numbers, right? Because if they are not like a good improvements, they're nothing to talk about, right? And you need to show the numbers. That's offline metrics, right? Users haven't touched this model yet. Okay, you show this result. Then, okay, compare this result with the old model, right? You do another round of evaluation. This model versus that model. Users haven't touched any of this model yet, but you need like another evaluation. Then you go like to the next level of evaluation, which is like live experiment. You put this model in a 5% of traffic, for example. I mean, you need to first of all get this 5% of traffic. That's a whole separate story. But you put it live, you get the metric. If it's good, then it's deployed, 100% of the traffic. What I'm saying is, on LLMs, I'm pretty sure people like will be doing like the same thing more and more and more. And that's what is happening today. People evaluating each single component of their system first, right? And there's a lot. And they evaluating the whole application, which is a really key part here, right? And you kind of like, you have this kind of like a black box with a small holes in it when you can see these numbers and evaluate the kind of like how the whole black box is functioning. So yeah, there's a lot of analogy in the quantitative approach that people use when they build complex systems.
Cool. Thanks, Dmitry.
Thank you. Thank you for the questions.
So I think we're running mostly on time. Yeah, you can just leave that up here. I'm going to invite the people from Alluxio to come up and do their raffle. Is that you, Eva? You're going to do this? Okay.
I don't want to scan this. Yeah, not delete. Okay. Hello, everyone. I'm Eva from Alluxio. I wonder if everyone has scanned this code yet. No? So there is a QR code on the sign-up desk. All right. One sec. Okay, we have 3 prizes today. 2 of the $50 worth of Amazon gift card. Another one is 100. So I'm going to announce the first one. One second. Okay. Yes, I do.
Does anybody who has not yet signed up for the raffle want to sign up for the raffle? No. Okay. Go.
Okay.
Oh, yeah. Oh.
Okay. Just wait for a couple minutes. Thank you. Okay, so I have the first one. I'm sorry if I mispronounced your name. Prahlad Wintash from Salesforce. Who is that? Oh, okay, congrats. So we will email you the digital gift card by this week. Congrats. All right, second one. Mauliana Steawan from MBK. You still here? Oh, congrats. So we will email you a digital gift card this week. So last one is $100 worth of gift card, Amazon gift card. All right. Give him a drum roll. Thank you. Fabiana Clement from Y Data. Oh, congratulations. So yeah, we'll reach out all three of you this week. Thank you so much for participating.
Thank you. Cool. So thank you guys all for coming. I'm really excited that so many people showed up for our first event here in SF. The OSS for AI community exists to get all developers access to resources to understand, use, and contribute to the development and direction of AI. I'm going to say that as many times as it takes, and hopefully you'll hear me say that multiple times at these meetups and you'll remember it. So yeah, for the rest of the time, please feel free to, say hi, network with each other. And if you want to speak at these events, or if you want to sponsor any of these events, please come say hi to me.
I didn't get the first contact you should from Observe.